about today's topic. Title was OpenTelemetry, OpenTelemetry, OpenLLmetry. My friend, how many of you have heard OpenTelemetry? Not just today, but have how many of you have heard it before? A couple of hands. So OpenTelemetry, I'll talk about it in brief during my presentation as well. But as Varun just mentioned, it is one of the projects within cncf space which deals with observability and monitoring. It's an open standard. We'll get into that deeply. But there's a lot of conversation and there are a lot of talks, videos, and documentations available today. Where if you want to understand what is OpenTelemetry, OpenTelemetry 101, etc., there are many talks. So today's focus is observability with AI. Anyone has recently watched any of the flagship videos or any of the tech videos from anyone recently on YouTube, social media? Any one video that did not mention the keyword AI? So no video or no product feature today or no marketing pitch today is incomplete without mentioning the word AI. Because everyone is working on building some form of AI integrations, some form of AI LLMs for themselves, or some form of chatbot. So my topic for today is how you can start observing and monitoring the performance of your AI generated applications, maybe generative solutions, your RAG, or whatnot. So let's get into that. So firstly, my introduction is already done. I just as by nature, I'm a full stack developer. I have about 8 years of experience. I've worked in contact center, I've worked in financial domain, and today I'm working in observability domain as a developer relations engineer. I am an active OpenTelemetry advocate at Relic. I work with customers who are trying to adopt. I promote OpenTelemetry in my conferences and my meetups, like I'll be doing today. And today I'm taking the role of AI RAG picker. Anyone know what is a RAG picker? RAG picker is basically kachra uthane wala. And today I'm AI RAG picker because I want to understand kya kachra ho raha hai in your application that we are trying to build with LLMs or any OpenAI based applications. So understanding what goes wrong is important before we build out any garbage based LLMs. So let's focus on that. Professionals, how many of you have heard this or how many of you have said this? 1, 2, 3, 4. Okay, almost everyone. Students, make a note of this. If you become a developer, you will say this. If you become an ops, we'll be hearing this from the developers. So this is a common phrase. I'm sure you must have heard it a lot. Today with container and all the portable architecture also, I've heard from our customers that we are not deploying our container right. So without Docker, it does not mean it works on my machine. It will work anywhere. With container also, people are complaining. So that's not going on. And that's constant because there's a lot of gaps. Now, why are there gaps? You build your application, you test on different suites, you test on your machine, you have your different architectures, you have application, you run your unit test, you may test it in different browsers, Firefox, Mozilla, Internet Explorer, if that's still around. So it works for you, but when it's time to deploy, someone else starts using it, it's broken. And you don't know why it's broken. So because there is this gap of what goes behind, this comes into picture. How does that get solved? That gets solved with observability. Now, observability helps you bridge the gap with anything performance, anything that goes wrong, your errors, your stack traces, or even if your package, it's not compatible within your infrastructure that you're deploying. Now, today's world is this. Every single company, every single customer that I have got a chance to talk with, or any of my solution consultants, the sales team is trying to work with, everyone is trying to build their own LLMs. We have OpenLLama now, which is very great. Everyone is grateful for. There is Light LLM. There are so many open source based LLM with which you can build your own LLMs, and everyone is just rushing to build their own solutions. Now, some people are against OpenAI, some people are against Amazon's models, some people are against Meta's models, but they want to build their own solution. Regardless it works or not, regardless it's functional or not, they are rushing towards this because this was the next hype. Now people are on this already working actively. And that creates what problems? Anyone remember the Google's stock drop after they released the Gemini? That's what happens. So if you're not careful, you don't know what is going behind the scenes. You don't understand what is going wrong. That's what will happen. Of course, not everyone is Google, but if it's minute fraction of your people, customers or users who are facing this problem, you'll have a lot of complaints. So to get understanding of that, we need to understand what's happening in the black box, because all AI applications are some form of black box. What do? You use some SDK, you have langchain, some other framework, again, Olama, OpenAI SDKs, anything. You're just passing the input, you're constructing your prompts, you're expecting some output. Now, what is happening behind the scene? Some API calls, a lot of compute, some chain calls. That's all that we know. But if something goes wrong, how do we understand that? How should we understand? Understanding that and having a gray area for that is a problem. That's why they are unreliable and they are unpredictable. So one example, if I want to build my application today, everyone must have used ChatGPT today in some form or shape, a free tool or a free wrapper or Google's Gemini itself. You ask any other question, any random question. I tried to build my own application with langchain, and I wanted to ask how old is Anil Kapoor. Anyone know the myth that Anil Kapoor is not aging? Everyone wants to know the diet, and I wanted to play around with my solution. So once I put that output, once I put that input, what happens behind the scene? Sequence of calls with langchain. I added a question that how old is Anil Kapoor, and it goes to GPT 3.5 model, and then it tries to use a third-party tool, which is search tool. So internally, it uses a search tool to see if it's available in its document database or in its vector store. So these are different aspects of building AI application, where you have your data store, your vector storage, your embeddings, and sequence of calls happens behind the scene. Now, once it reaches the search tool, it tries to find something. If it does not, it tries to use another tool. It tries to use some search engine. In this case, I used Google Search API. It's free to use. You can build your own custom search engine, use the API to build your own search engine with whatever you want. You can build it for your colleges, you can build it for your organizations as well. And with that SDK, you can also plug it in as chain operation to your AI. Now it goes to your Google Search API. It finds the relevant paragraphs. What do you see on top of Google once you search anything like this? How old is Anil Kapoor? You get a summary. Google result gives the same, so it pulls some relevant paragraphs. It does its AI magic, where it's trying to understand, format the data. It's trying to make sense, like answer the question with relevant paragraphs. And it gives the answer that Anil Kapoor is 64 years old. Now, these sequence of calls, if something goes wrong, all you're seeing is a terminal or a UI. There is no REST API call if you're running it in the browser. It's a simple wrapper that you will see where it's sending a payload, which again does not make sense. So how do you understand if something fails? May it be search, or may it be after the search was retrieved, your SDK has failed on the client side. What if you ask something more complex? Anyone knows the Sachin's famous term, ILA? So I asked a complex question. What is Anil Kapoor's age divided by total number of world records held by Sachin? Now why this question? Because I want to challenge and put a random garbage question to my AI that I'm building, because AI is going to replace this. So I added this question, and the sequence, if you notice here, what happened? First, it does the search action. It finds Anil Kapoor's age. Then it tries to think. So now that I know Anil Kapoor's age, I need to find the total number of world records held by Sachin. And that's the second action step. It does a search on Google, if you see the next action, and it's pulling a lot of records from Google search API. Then it tries to filter out how many actual word records are held by such API. Then it tries to add another action. There is searching within the response. And finally, it performs a calculation. So that's the third action in one request that you have started, where it says total records held by such is 19. Now the final output to calculate is 64 divided by 19. So 19 records are held by Sachin, 64 is running the position, and it's doing the calculation. So behind the scene, it's doing a lot of complex operations for you, which looks very simple on the chat UI or in the terminal. Now, if you are a developer, someone who is using ChatGPT on daily basis, now that we are all used to it, how many of you think what's actually happening with this? So this answer took 30 seconds. Once I put the question, it took 30 seconds to process on my local laptop because everything was running locally on an M1 Max laptop. So imagine if you are asking, complex question like summarize the release notes for cncf Kubernetes 1.2.3.1. What happens? How much compute goes behind the scene? How much time it takes? How much time it takes for it to format and perform all the actions? And if you are building your apps, something goes wrong, how do you figure it out? I heard someone was Java developer. So what do you do traditionally? You start looking at your stack traces. You start looking at your memory dumps if it's a complex application. Or if you have microservices, you start understanding the traces, where exactly it has to be. But with this, how will you understand what's going on? Because you're basically taking your input, black box where you put it, and then output out. So that's where tracing comes in. Tracing is not new to the observability world. This has been existing for about 10-15 years. Twitter initially started building their own tool, where Google was also working parallelly. They built their own tool with Jaeger, and Twitter also worked on distributed traces, where if anyone of you have read about Twitter's architecture, they had at one point about 9,000 microservices in-house on-premise without cloud. And all that they were tracking with distributed traces. So tracing is not new, but tracing within LLM applications, that's going to help us at least reduce the noise and get to the root cause. Now, same operation that I did, what does it look like with tracing? So this is any typical langchain application or basically any AI application. It could be langchain or it could be any custom built, Ollama-based application. So once you send the prompt, what happens behind the scene? We saw in the output in the terminal that there was a chain of execution starting from OpenAI call, then it goes to tool, which is search, then it changes it back to OpenAI, where it's trying to make sense of the output that's received from the search API. Then it finally is able to do the calculation operation after filtering out the data from the paragraph. After that, it again hands it back to langchain to do its chaining operation, and finally it gives to OpenAI for the output. Now, with tracing, you are able to see all this step without having any observability in place. This is just running behind the scene. All you are saying is input, output, and in between you are seeing the progress bar going round and round. So all of the YC startups, I think this is a plug. So a lot of Y Combinator startups are working on applications today, which is appeasing to a lot of venture capitalists to get the funding. So even if there is no AI, everyone wants to build some form of AI application. How many of you have heard a lot of AI startups starting and then silently vanishing? Now why does that happen? Any guesses?
Product market.
There's no product. There are a couple of products already existing in the market, not naming names, but that's just a wrapper around OpenAI, and that's being sold as AI application. So there are a lot of startups who are also working on solving observability of what is happening if it's OpenAI, trying to understand what happens behind the scene. And then comes this, which is Vela. This is the specific startup which is working on solving this observability, where they have actually launched AI observability, but this is a closed source application, not an open source. So enterprises, it can help, but for startups or mid-level or early projects, this does not help. There is another solution which is LangFuse, which helps you build your applications and observe them. But again, it provides all your tracing. It's a paid tool. One more, Helicon, provides LLM observability for developers, easy to use, has a lot of limitations. Then Fiddler, there's comes this Traceloop, which is what I'll be talking about. Traceloop is an open source project. It's an organization, but they are working with OpenTelemetry, where they are using OpenTelemetry to build LLM observability as part of the OpenTelemetry ecosystem. And there's one more, which is Athena, but I'll be talking, which is part of Y Combinator. I'll be talking about Traceloop OpenLLmetry. The OpenLLmetry is the actual name of the framework and SDK that will be focused on. Lastly, there is one more MyTime, which is part of the Y Combinator. This is again, this is a very cheap one, almost free, but there is no free with any AI-based application. You have to pay for storage, you have to pay for networking. So you can start exploring that, but for storage, storing the observability data, that will still be a challenge. Now, with all this observability, what happens behind the scene? A couple of you raise the hands, who know OpenTelemetry. How many of you have given it a try, or have heard in the organization that you are introducing OpenTelemetry? So OpenTelemetry is an open standard. It's not one framework or one language or one SDK. It's an open standard, and it's a Linux incubating project in cncf space, which Varun has already given you the background about what are the projects that are part of cncf. And this is one of the fastest growing projects. I'll give a highlight of how fast it's growing. So it's an open standard. Any one of you have used Prometheus? Yes. Some traditional monitoring tool, with CI/CD or Windows-based monitoring. What are the different problems with this? If you are using Prometheus today, exactly. So today, if you add any kind of monitoring or observability from a specific vendor, you get locked in. Now, what is locking in? If you have to migrate to a different vendor or a different tool, you need a complete re-architecture, which can be 6 to 8 months of engineering efforts. OpenTelemetry solves that, where you spend your efforts once to instrument anything, and you have to just change the output where it's getting stored. So that's what OpenTelemetry is trying to solve. Any of your source, may it be infrastructure, your SDK, your Java, your .NET, or your microservices, all of these applications and infrastructure can be instrumented, and they can be sent using the OTLP standard endpoint, which is the OpenTelemetry format. And the best part, why OpenTelemetry is growing so much, is its vendor neutral. Today, you instrument your application. The most basic example I can give is you instrument your Java application, and you don't like one particular UI. For example, you are trying to use Jaeger for distributed tracing visualization. Maybe you don't like it because it's too old. You try to use OpenUp. But for that, you don't have to change anything except for a single UI, which is the export UI. You just change that, and anything that's already captured will be sent to your OpenUp. That will become your default storage. And you can also send it to multiple sources. That's how OpenTelemetry is helping the ecosystem with observability. Now, why it's growing and how it's growing. If you notice, I'm not sure if it's visible to everyone, but the orange dot here is the OpenTelemetry, which is right behind Kubernetes. So that's technically the third fastest growing project apart from Linux. Kubernetes is the second project which is fastest growing and it has been adopted. And OpenTelemetry is not just being contributed. a lot of people are already adopting, including Microsoft, AWS, Google, Relic. Everyone is adopting, and they're working on building this standard even better. And because this is required in today's industry, in your own company, you must have seen 4 different tools being used. One team will be using some other tool, one team will be using some other tool. To solve that problem, OpenTelemetry helps you get a standard where everyone can speak the same language. Now, there are 2 ways to get started with OpenTelemetry. Now, this is the background before we get into LLM, so you understand the basics. So, OpenTelemetry has two ways to get started. Maybe your application or infrastructure. One is automatic instrumentation, second is manual instrumentation. Now, with automatic instrumentation, it's like a zero code instrumentation. You just drop your SDK or your agent, and it will start capturing all your traces, metrics, and logs. With manual, you get an option to customize. You want to capture some specific metrics. You want to modify your tracing, add additional span or additional custom attributes. You are able to do that. The SDKs provide you with that option. To get started, for example, the most basic Python example, all you have to do is add a couple of packages. One is the exporter, one is the OpenTelemetry distro for Python, and you just execute that with your main Python application. Similar to Streamlit or any UVCon server that you start. You just start with that, and all your application will be instrumented, and your observability will be in place with OpenTelemetry SDKs. What do you get once you start instrumenting? You get all the information from what's the library name, which APIs have been called, what are the metrics, what function got called, how much time the function took to execute, what database it was trying to talk to, how much time it took to execute that query. All that information will be captured with automatic instrumentation. Now, with manual instrumentation, there is a lot more effort. You have to add a lot of more packages, and you have to define your tracer. It's good because manual tracing is an advanced version where you get more control of how you want your observability data to look like. If you're an enterprise, you don't want to see a generic data. Maybe you don't want to see HTTP 200s. You only want to focus on HTTP 400, 500s, or anything that's fake. So that's where manual instrumentation will be helpful. Now, tying all this back of the LLMs, building LLMs, using OpenTelemetry, how we can get started with monitoring our LLM applications with OpenTelemetry. So with OpenLLmetry, we'll have the same sequence, but we'll be able to get all this tracing, where we will be able to see what exactly has happened in each step. Once we give the input, where it reaches the agent, where langchain is executing, what input and prompt was provided to OpenAI, what prompt was provided to search automatically by langchain, you'll be able to get insights on which step is taking the log. Because one thing, if you have heard in the AI world, prompts, tokens, embeddings, these are the primary factors which increases the cost. So how do you actually optimize them? You need to have the data for it. How do you get that data? You add observability. Now, with prompts, number of tokens, the temperature, with number of different models available, what do you want to capture? The durations, what is the trace ID, how much time it took in your langchain application. And if you actually want to get detailed metrics, you can also do custom instrumentation, which is the manual part. It's almost as same as you do your manual instrumentation with any language. You use the same APIs which are available. As I mentioned, OpenTelemetry is a standard. So any language, any framework will have the same set of standards, same set of APIs. So span remains same across the whole ecosystem. Then comes your tokens. So if I want to capture the number of tokens utilized in each request, I can just use that span.set attribute where I'll be able to capture the total number of tokens used in each request. This will help me calculate the cost. I'll show you how it looks in the real world. And OpenLLmetry, the actual SDK. This is an SDK with respect to specific of your LLM applications. This provides you automatic implementation for all your AI applications. Currently, it's supported with Python. The JS SDK is in beta. It should be released in a month or 2 months time. But with Python, it's stable and production ready. You just have to drop the SDK in your application and will start working. What does that look like? Too fast. What does that look like? Once you drop in, you start capturing on all the data, your tracing information, your metrics. You get the data. Now you start wondering what can I do with it? What can I do, with the LLM tokens that I'm capturing? What's the response time? You get all the information like execution, your breakdown of tasks, how many calls have been made, and including the details of errors. Something fails, all that data will be captured as per OpenTelemetry standards, where each of your trace spans will contain that error include in the sequence. So in this example, there is one request that I made where I'm trying to do some calculation. From the agent side, the request has gone out fine, but in the calculation step, something went wrong. Now, what's the error? Unknown format. It's not able to do a numerical expression calculations because it could be a paragraph, it could be a string. It's not able to operate. So you need to refine your data. You need to add some tools, or you need to just add another chain to refine your data and capture a specific data that you are trying to prompt. Now, is this visible at all? Okay. So this is what it looks like. Is it possible to zoom?
It's full screen. It's disabled. I forgot to enable that.
It's okay. So if you see my cursor, this is the UI for capturing the traces for your LLM application. I'll share that slide so you will have better visibility. But on the left hand side, if you see, this is the sequence of operations visually. So it started from agent executor, which took 9 seconds. It went to the LLM chain, which called chat OpenAI. It went to search, then another LLM chain, which called chat OpenAI, which was using GPT 3.5 turbo, which took 1.5 seconds. Then it comes to search again and the langchain. So the whole sequence, you are able to get the direct picture what happens behind the scene. And on the right hand side, you get what was the input and what was the output actually provided. So if you are deploying any LLM application, chat based or anything for your users, how your users are using, what actually our users are trying to put the input, you will be able to get these details. So if anyone is trying to abuse or mistrain your agent or data, you can capture this here and you can add guardrails for your LLM applications. One more thing, again, I know it's not very visible to people on the back, but on this right hand side, you will see there is total number of tokens that was utilized for this request, which is 1,900, and the approximate cost for it, which is $0.001. Now, dollars is what's important for any business which is trying to build application. You save the dollars, you will be considered as a good developer. Now, tracking the cost. How do we track the cost? All the attributes about token utilization, the prompt size, the completion, the rate limiting, all this is captured default by OpenLLmetry. With OpenAI dashboard, you are able to see how your cost is going up. But do you get any insights if anyone has tried that? You don't. All you see a bar graph that my cost is going up, which will also raise the heartbeat of your manager. That cost is going up. Let's start reducing that. We also had an incident when we had to plot the ChatGPT usage internally. Then how do you actually calculate the cost? You start capturing your token information. Any prompt is divided into different tokens, and each token will have sub-tokenization. Now, there is a different tokenizing algorithm with different providers. GPT has its own mechanism, Claude has its own mechanism, but the tokenization concept remains. Once you have your tracking for all your tokenization, while OpenAI provides that. It's a UI where you can, add your prompt or a prompt template and get a breakdown of how many tokens will be utilized and how many characters are there. But this is more of a, just analysis. It's not real-time data, so you cannot act on it. It's something. It's just estimate where you can say that estimatedly $100 will be spent, but it's an estimate. Estimates will change. How do you get the actual, results? You start tracking the tokens with your OpenLLmetry, where regardless of the model that you are using, GPT 3.5 Turbo with 4K context or 16K context, with tokens you will be able to get the real-time dashboard, how much dollars you are spending. And with that, you will directly get the information like completion tokens is 42, prompt tokens was 221, and total tokens utilized was 263. Again, I'll share this slide, so don't worry, you'll be able to see this. And you can start, understanding your telemetry by querying, depending on the platform you're exporting. This is one example where I'm exporting it to New Link, the raw data of OpenTelemetry, and I'm able to see what's the average completion tokens since last 2 days, where I can see, if something has gone up, if the prompt template has changed or prompt is not good. If we go back to my second question, checking Anil Kapoor's age divided by number of trophies that Sachin Tendulkar has. Okay, do we have time for them? Okay, so I'll just showcase some of the real world scenarios of how the tokens are calculated.
You can just zoom it up.
Okay, so this is the raw data that I'm receiving. If you see the query here, it's from span event where I'm taking the average of total prompt tokens from the GenAI usage multiplied by the average rate of the tokens provided by OpenAI. And I'm able to get the total cost. Since last 1 day, there's only 0.633. And then if I want to deep dive into that further, this is my application. Let me zoom this. This is my application. This is the sequence of operation that I prompted. What is the age of Anil? Now, if you see here, there is the agent executor workflow, and we are able to see all the attributes which are captured by the OpenLLmetry. If you will see here, instrumentation provider is OpenTelemetry, name is agent executor, what is the engine, and we are able to break down into the details as well. What's the application name? What is the timestamp? Not just that, you are able to see the information for each sequence of operation that happens behind the scene. The first was LLM chain task, where if you want to see what was the prompt, so what was the input provided, what was the entity name, and what happened behind the scene, everything will be able to see here. So a lot of garbage information I was trying to abuse the agent that I was building. So here I'm trying to see how many number of movies Ranbir Kapoor has done and number of actresses he has worked with. Bollywood is garbage. So that's why it's good to train that data. And then comes the chat OpenAI trace, where you'll be able to see that what is the content provided, what's the different tokens that's being captured, what is the prompt, which is the primary concern for cost, and then comes the number of tokens, max tokens that can be utilized, what is the model, what is the temperature, what is the exact model that we are trying to use, what is the system. Since I'm using langchain, I see langchain. And this will remain the same, the data will remain same regardless where you export it. If you export it to Grafana, same data will be available because SDK captures it at the source level. Now, one thing about calculating, understanding the trace even better, there is another tool called Langsmith, where you will be able to visualize what the actual cost is from, depending on your application. Again, this is free tier where you can export all your data from your OpenLLmetry just by adding the Langsmith API. So I have 4 different applications running with different models. I see the error rates in each of these applications, if it's streaming, and how many total number of tokens have been utilized. So in last one day, since yesterday morning, I have spent almost $2. $1 for first application. What is the latency? You get all that information directly. And this will be the prompt which I have used. We'll see what is the input, the latency, the total token cost, and other details once I click on this. Let me zoom this. I hope this is visually better for everyone. Now, if you see here, this is the sequence where it's running. It has taken 23 seconds. Your different trace of GPT-4, search operations, your calculation, what happens behind the scene, including all the metadata that is available here. And there are a couple of dashboards ready-made available within this itself, where you can check if you are running your applications in multi-threaded model, or if you want to monitor the complete overall volumes and latencies, you are able to see that in a single place. Again, it's free to use tool. There, it's easy to use. I'll also share the code sample so you can get started. If you want to get started quickly, you can start doing so. But if you want to, get in the advanced mode, you already have some form of observability. You want to capture, the difference between different models that you're using. Maybe you want to use Bedrock. Bedrock itself has tons of different models. Anthropic, Cloud, it supports almost all the models that are available in the market. So how do you want to get, if you want to capture the details from that? Again, it's out of the box supported for almost all the models in the market today. You just have to add the SDK and it will start capturing the information that's available in your application execution set. And then if you want to optimize between one prompt to other prompt, which one is working better? For example, the first prompt was taking only 152 tokens. Second one is taking only 200 tokens. Once you have the telemetry data, or if you want to add custom attributes, similar to how you do manual instrumentation with OpenTelemetry, you can capture that information, create a dashboard, or create some alerts and start analyzing that data easily. And if you want to use multiple models, what if you want to use GPT-4, Claude, or Llama all together? Maybe you have a sequence of operation, you just want to play around, that will be supported. So just drop in the OpenLLmetry SDK. It will capture from Hugging Face, your Meta's Llama 2, or your anything commercially closed. If you're trying to use something NVIDIA GPU also, it captures the GPU metrics also. Anyone tried the EC2 instance with NVIDIA GPU? How much did you pay? Good answer, you did not, but somebody paid. So if you are trying to build applications on NVIDIA's GPU, that information will also be captured, which is supported out of the box. The sequence will be similar, where you can start importing different models which are part of the langchain core library, where you can import OpenAI, Anthropic. You can use Replicate to check the model differentiator, and you can divide the workflow between 3 of the models. It can be OpenAI, Anthropic, and Meta. So if you want to experiment and capture which is the best performing models, you can do so with this observability data, which will be real time and raw data provided to you as a developer. That's about it. One final thing, there is other framework which I could not cover is OpenLit. It's up and coming, which OpenTelemetry is also actively working with. It's based, the developer is based out of India. You can explore that. That's also automatic instrumentation. You just have to add 2 lines, just include OpenLit library as part of your Python application and do the OpenLit.init, and you will get the similar experience. They have their own UI as well. So they provide OpenTelemetry collector bundle. So you can store your data within ClickHouse and collector, and they provide the complete setup for you. That's another open source framework that uses OpenTelemetry under the. That's about it for today's talk. I hope you liked it. There will be a couple of questions in the quiz that I've added. Hoping you were attentive and I did not. Thank you.
Does anyone have any doubts?
So we can use the OpenLLmetry for microservices application also.
Yes.
So Prometheus is different from OpenTelemetry.
Yes, Prometheus it's a tool in itself. With OpenTelemetry collector, you have built-in Prometheus extractor or metric extractor. So slowly you can replace your Prometheus with OpenTelemetry collector itself.
It can be integrated with Grafana.
Absolutely, 100%.
Thank you.
Also,
Yes.
the means you have exported the data into New Relic.
Yes.
So have you built the dashboard for that, or we can customize our dashboard according to our need?
So whatever I showed, I was trying to explore the raw data. You can create the dashboard. We do have one out of the box dashboard available in the store with trace loop. So since I'm using trace loop OpenLLmetry, the dashboard will give you the data. But you can easily customize.
If you want to use some any other open source tool other than New Relic, so can we?
Yes, 100% because that's the base of OpenTelemetry. You don't want to export to New Relic, just change the URL to Grafana, OpenObserve, or Jaeger, the most basic tool for visualizing tracing. You can do so.
So we were talking about why we want to use this OpenLLmetry, and we discussed one example of Google stocks fund. That particular case happened because the AI hallucinated, right? But so I was expecting any mention of tracking hallucinations using the OpenLLmetry, but I didn't see any, like, because we are tracking errors in case some calculation mistake happens. But how about when the input is a text and an output is a text, but no calculation was performed and it hallucinated? So we would not be able to track it based on what I understand up until now.
Good question. I did not highlight that because focus was on simple generative AI or RAGs examples, where it's just chaining operation. If you are building such complex application, where you're giving the text input, you will have a lot of different sequences that you want to capture and some guard. With that, on the hallucination part, once you start capturing, your data prompts and what are the sequence of operations that's happening behind the scene, you will be able to see, the different data like temperature, what was the actual prompt converted from the original prompt. That's where you will be able to get that information. This was focused solely on very simple examples where I'm just using OpenAI and search. But that's also possible because you get the raw telemetry data from the execution.
It's on top of like any application basing you do, right? You can like automated observability can only do so much. You being application developer, once you have the telemetry, you can analyze on your own that okay, if this was right or not. Similarly with OpenLLmetry, my understanding is you will get that observability and you will need to write those queries that okay, this was probably expected, this is not, and with that telemetry, that is that something you were hoping for? Yeah, that makes sense. Yeah.
That's where manual instrumentation will come in because you understand what's actual hallucination. Each model has its own different things. So once you start with manual instrumentation, you can define, what's expected in this specific section.
The point is they still have product with it.
So my question is like, what is the benefit of using the OpenTelemetry instead of Prometheus? What is the benefit of using and like Prometheus only takes logs about the infrastructure, not about the applications inside the infra. So how can we use that to like monitor the applications logs and using that?
So you actually answered your own question. Prometheus only focuses on infrastructure metrics or process metrics. With OpenTelemetry, you will get the function level metrics as well. So that OpenTelemetry focuses on three pillars: metrics, logs, and traces. Prometheus focuses on only on metrics. So you can also get the infrastructure metrics with OpenTelemetry connector. So it's complementary. Prometheus focuses is metrics. With OpenTelemetry, you can focus on other aspects, which is logs and traces too.
How can we integrate that? Like it is like agentless or how?
So each language, each different source has its own SDK and different options which you can deploy and start utilizing.
Fine.
So there will be a quick demo on that.
Look forward to that. Any other questions?
Friendly fire.
So my question is not straightforward with the OpenTelemetry. It's more about the data you are collecting. Since you are already exporting tokens, what prompt you are using, what user is using. So at the back end, do we mask the data? For example, we don't want all the data to be available to the person who is deploying, right? We just want some data to be seen to the user. So it is possible to apply a policy on a level of attribute that, hey, it's masked, you can't see these values. So possible.
Yes, so this will go with the same principle as any telemetry data. So you use collector where you apply policy what data you want to obfuscate or drop it.
No, that is like you don't want to collect it, but at the source you want to filter out who is actually viewing.
So OpenTelemetry collector is will be your source where you mask it.
Oh, basically.
On the backend you cannot do. Backend will vary, what platform offers. So with New Relic you can mask on the server side after it's received. Maybe other open source tool does not offer. So if your best chance is to do it on OpenTelemetry connector.
You're using like for example, now. Okay. So there are a lot of formal filters are there which can do this job.
So that is like a filtering on a source level from where you're collecting. And see, I want to collect it, but the level of permission given to the user depends on the level of clearance from organization to organization. Like a data engineer can have access to that from,
So
but
that's
user
Grafana, right? So Grafana, I mean, we have done that. Every enterprise does that. So you can integrate your TAM and whatever entitlement software you have got. So you basically integrate onto the visualization side. Either you do it the source side or you do it the destination side. There are no.
Yeah, that
So
control you'll get in the platform.
So the Grafana has it. It's pretty super mature. You can do that at a tenant level.
Because that's user control, not telemetry control. So that will be depending on the platform where you export. Yes, absolutely.
Any other questions?
I'll be around if you want to ask a question offline, till the end of this meetup. So thank you everyone. You can reach out if you want a specific source code as well. I'll be happy to share it with you. Thank you.
Thank you so much, Zameer. So next we have Ajay Tiwari. He's a vice president at Morgan Stanley with over 15 years of experience in technology and 6 years as an observer.